In this video, we will look at permutations and combinations. Now, the important thing to remember about distinguishing between permutation and combinations is to remember that with permutations, the order in which things are arranged matters, and with combinations, the order in which things are arranged does not matter. And I'll give you examples of both. So let's start with permutations. So with permutations, remember that the order of the arrangement does matter. And so a really good example that illustrates this is if we were trying to choose a beauty queen. So in a beauty pageant, if we have a queen and then the first runner-up and the second runner-up, the order in which we select those people really does matter. The queen is going to be crying for a different reason than the first runner-up. The queen is crying because of joy. The first runner-up is crying because she didn't win the pageant. So in this case, the order really does matter. So let's say that there is a beauty pageant where there are 8 girls in the pageant, and from those 8 girls, we're going to choose the queen, the first runner-up, and the second runner-up. So the question is, how many different arrangements are possible? Now this is slightly different than if we had 8 girls and we were going to award 8 prizes. That's when we'd use the 8 factorial and get our answer. This one's different because we have 8 girls, but we're only choosing 3 of those girls to win the queen, the first runner-up, or the second runner-up. So we can look at this a couple of different ways. First, let's just kind of think through it. So how many choices do I have to select the queen from the 8 girls? Well, if there's 8 girls, we have 8 that we can choose from. How many choices do I have for the first runner-up? Well, if I've already chosen one of the girls to be the queen, that means I only have 7 to select for the first runner-up spot. And likewise, for the second runner-up spot, I've already chosen 1 to be the queen, 1 to be the first runner-up, so now there's only 6 girls left for the second runner-up. So the question is, how many different ways can we select these girls? Total, how many different results are possible? Well, we're going to get 8 times 7 times 6, which, if we calculate that, is 336. Now, we have a formula that we can use to calculate permutations, and here's the notation that we use. NPR. So NPR, N is the total number of choices that we have. So for example, in that example at the beauty pageant, we had 8 people we can choose from. R is the number that we're going to select from our pool of 8. So we chose 3 for the winners. So it would be 8P3 for our notation. But the formula looks like this. NPR is going to equal N factorial over N minus R factorial. So in the case of the beauty pageant, we had 8 girls, and we were going to choose 3 of them. So that would give us 8 factorial over 8 minus 3 factorial. And 8 minus 3 is 5, so I have 8 factorial over 5 factorial. And if you remember, that is 8 times 7 times 6 times 5 times ... over 5 times 4 ... and everything from 5 on cancels out, and so that's how we end up with the 8 times 7 times 6, which you should see matches up with exactly how we solved it previous to this.